Today's lesson in pre-cal is about the average rate of change, which is a fancy term for slope, and it's about even and odd functions and how to describe something's symmetry. We've kind of touched on that before, but we're going to touch on that again today. For part A, we're talking about the average rate of change. So the average rate of change, definition here, is the slope of a line through 2 points. And that's x1 and f of x1 and x2 and f of x2. You'll notice that the major change here between slope and average rate of change is normally I would call this x1 y1, x2 y2. I'm still talking about a y value, I'm just saying the function at that point, so I'm labeling it a little bit differently. This is also called the slope of the secant line, and it's m secant. So that's just kind of some notation. To find that, we're going to do the change in y over the change in x, or f of x2 minus f of x1 over x2 minus x1. Again, that's y2 and y1. I'm just showing you this different notation because that's the way that we notate that stuff in calculus. And if you're going on to that, I don't want you to be confused later on. So, for example number 1, let's look at several things. First of all, your function f of x is x to the third minus 3x. And for part A, I want you to tell me the slope from x1 equals negative 2 to x2 equals 0. Okay, first thing you want to do is find your f of x1 and your f of x2. So f of x1, you're going to plug in negative 2 to the third power minus 3 times negative 2. Just plugging in negative 2 everywhere that I see x, or x1 in this case. Negative 2 to the third is negative 8. Negative 3 times negative 2 is positive 6. And so f of x1 is negative 2. For f of x2, I'm plugging in 0. So 0 to the third minus 3 times 0. 0 to the third is 0. 3 times 0 is 0. And 0 minus 0 is 0. So I've got my two values. Now, to find the slope of the secant, I'm going to do f of x2, is 0, minus f of x1, which is negative 2, over x2 minus x1. This ends up being 2 over 2, which is 1, and so the slope of the secant through the points negative 2 and 0 on the function x to the third minus 3x is 1. It's a long way of saying the slope between these 2 points of this equation is 1. Part B, let's do the same thing when x1 is 0 and when x2 is 1. Now, the only difference here, guys, I've already solved for f of x1 when it was f of x2. So f of x1, or f of x at 0, is 0. We figured that out up here. I'm not going to redo that, just for the sake of time and space. If I'm looking for 1, I'm going to plug in 1 to the third minus 3 times 1, which is 1 minus 3, or negative 2. Now I'm going to go ahead and find my slope. So, negative 2 minus 0 over 1 minus 0 is negative 2 over 1, or negative 2. Notice that the slope is not the same as it was when I went from negative 2 to 0. All that should mean to you is this is not a linear function because the slope is changing. That should make sense. It wasn't linear to begin with. It had a cubic at the front. So that's how you find average rate of change. Part B for today is talking about symmetry again. Remember we learned last week or 2 weeks ago how to do a test for symmetry. And today we're just going into a little bit more detail of what type of symmetry a function might have. Is it even or odd? A function is even if it's symmetrical to the y-axis. That means when you plugged in the negative x, it equaled the original. So that's even. A function is odd if it's symmetrical to the x-axis. That is if f of negative x equals negative f of x. And we'll look more at that in a little bit, if it's the exact opposite. Okay, let's look at some examples. Example 2. So we've got g of x equals x to the third minus x. We're going to plug in negative x for x. We're going to do that every time. So g of negative x, I do negative x to the third minus negative x. And let's just test. Okay, negative x to the third would remain negative. Anything to the third power keeps its sign or retains its sign. And then I've got a negative negative, so I've got plus x. Okay, if I have this, this is not exactly the same as the beginning. However, it is opposite. This was negative, this is positive. Right? If I can pull a negative out, or take out that greatest common factor of a negative, what remains is x to the third minus x, because a negative negative makes positive, negative here would be distributed. And this is the same as a negative g of x. It's the exact opposite of the original. Because it's the exact opposite, this is an odd function. Let's look at one that's even. If I have h of x equals x squared plus 1, and I want to plug in negative x. Negative x goes in here. Negative x squared is x squared plus 1. That's the original function, so this one is even. Okay, now, some of you are going to notice a pattern once you get going on this, so I want to kind of give this to you. If all exponents are odd, like 3, 1, 5, etc., then the function is odd. So here the exponent was 3 and this exponent was 1. That's what made it odd. Here, if all exponents are even, like x to the second, and this one is really x to the 0 power, which is what made x go away, all even powers, the function is even. If there is a mix of exponents, let's say I had x to the third minus x squared, so an even and an odd, then it is neither, meaning it does not have symmetry. Okay, your assignment for this is a 7. It's page 63, and it's numbers 63 to 67, 71 to 75. Good luck, and let me know if you have questions.